Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for class 12 of CBSE. The first problem is the application of infinite GP in probability. The question goes like this. Three men, capital A, capital B, capital C, play a game of throwing a die alternately. The one who gets number less than 3 first is considered to be the winner. Find the probability of subdivision 1 A winning the game, subdivision 2 C winning the game if A starts the game. That is a question given to you. I'll just show you the question. I'm not going to write the question on the board. I'll just show you the question. Just see here. Let me just see here. When a die is thrown, sample space equal to S is equal to 1, 2, 3, 4, 5, 6. P of getting a number less than 3. It will be anyway having 1 and 2. This is by n of s, which is 2 by 6, which is supposed to be is equal to 1 by 3. P of getting a number greater than or equal to 3. It will be 1 minus 1 by 3. Or you can very well write n of 3, 4, 5, 6. 4 by 6 is also 2 by 3. Either way you can write. Now subdivision 1. Probability that A wins the game. A wins the game if A starts the game. If A starts the game, which will be equal to, listen, A will start throwing the die. If he gets a number less than 2 or less than 3, 1 and 2, if he gets any of the two numbers 1 and 2, he is considered to be the winner, and B and C will not even get a chance to throw the die. That's very important. Now for P of A wins, or wherever I have the application or, I use the addition here. P of A loses, B loses, C loses, A wins, and it goes further. I have no idea when A is going to win. A wins in his first attempt, or A wins in his second attempt, or A wins in his third attempt, etc. Now winning means he is getting number 1 or 2, definitely 1 by 3. Losing means he'll get A gets 2 by 3, B gets 2 by 3 probability, C is also 2 by 3 and 1 by 3 and so on, plus etc. This is the application of infinite GP, A by 1 minus R, where my first term A is 1 by 3, my common ratio R is nothing but 8 by 27, 2 cube by 3 cube, which is equal to 1 by 3 divided by 1 minus 8 by 27. 1 by 3 into 27 by 27 minus 8. Here I will get 9 upon 19. 9 upon 19. 9 by 19 is the answer. 9 by 19 is the answer for the first one. Second subdivision. Probability that C wins the game. C wins the game if A starts the game. Who starts the game? It matters a lot. A starts the game, which is equal to P of A loses, B loses, C wins, plus P of A loses, B loses, C loses, again A loses, B loses, C wins, and so on. It goes like this. Now it will be 2 by 3 into 2 by 3 into 1 by 3, plus here again 2 by 3 into 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 1 by 3. This is how it goes. 1, 2, 3, 4, 5. 5 persons losing. A loses, B loses, C loses, A loses, B loses. plus etc. I should not stop here. Here I am not going to write the formula again. Here my A is 2 by 27. My R is again 8 by 27. It's the same as 8 by 27. Let me just apply the formula A by 1 minus R. Since there is lack of space, I will write 2 by 27 by, here again 1 minus 8 by 27, which is 2 by 27 by 19 by 27, which is reduced to 2 by 19. If in the same question you are given B wins, it will be 1 minus sum of these two. It will be 1 minus sum of these two. Yeah, this is 4 by 27, sorry. This is 4 by 27, therefore my answer is 4 by 19. Then if the same question, if you are required to find at the third subdivision B wins, it will be 1 minus sum of these two. That will be the answer. Let me just repeat. When a die is thrown, sample space S is 1, 2, 3, 4, 5, 6. There are 6 spaces, each having numbers 1, 2, 3, 4, 5, 6. P of getting a number less than 3, getting 1 or 2, 2 by 6 by n of S is 1 by 3. P of getting number greater than or equal to 3, it's a complement of this, or n of 3, 4, 5, 6 by n of S, 4 by 6, which is 2 by 3. Probability that A wins the game, if A starts the game. Who starts the game? That's very important. Here A may win in his first attempt itself. Then B and C will not even get a chance to throw the die. If A wins in his first attempt, or A loses, B loses, C loses, A wins. That is, A wins in the second attempt, and so on. It goes further. I have no idea when A is going to win. Therefore, it will be 1 by 3. Loses means getting a number here, 3 or 4 or 3, 4, 5, 6. Therefore, 2 by 3 and 2 by 3 and 2 by 3 plus 1 into 1 by 3 plus etc. It's an infinite GP where A is 1 by 3, R is 8 by 27. Now 1 by 3 and 27 by 19. Therefore 9 by 19 is the answer for the first subdivision. Okay, probably that C wins the game if A starts the game. P of A loses, B loses, C wins. Thus P of A loses, B loses, C loses, A loses, B loses, C wins, and so on. Therefore loses means 2 by 3, B loses 2 by 3, wins 1 by 3. Again 2 by 3, 2 by 3, 2 by 3, 2 by 3. There are 5 such 2 by 3s multiplied. 1, 2, 3, 4, 5 and 1 by 3. A loses, B loses, C loses. A loses, B loses. Then C wins. C wins in his second attempt. That is the meaning. Here A is 4 by 27. By mistake I wrote it as initially 2 by 27. It's 4 by 27. Sorry. Divided by 1 minus 8 by 27. 8 by 27 is my, other than 4 by 27, I have my, other than these three, this is my R. This will be my R, 8 by 27. Now for 4 by 27, similar to the previous case, it will be 19 by 27. Or this 27 goes up. Therefore it is reduced to 4 by 19. If in the same question, if you are required to find out, simply, if you are required to find out your B wins if A starts, it will be 1 minus some of these two you can write, or you can even very well write there P of A loses, B wins, plus P of A loses, B loses, C loses, A loses, B wins, and so on. If you try to find out, we will get the same answer as 1 minus sum of these two. Both will be the same. Both will be the same. Both will imply the same. 1 minus sum of these two probabilities you can write, or similar argument what we have done here, the same thing you can do anyway. The next problem goes like this. I need not show the pages to you. It is simply a simple problem on integration. Integral secant cube x dx. I assume I to be integral secant cube x dx. What I will do here is I will write it as secant x and secant square x dx can be written as secant x into d of tan x. Derivative of tan x is nothing but secant square x, which can be written as secant x tan x minus tan x into d of secant x. Let me write the formula behind this. Integral u dv is equal to uv minus integral v du. This rule is called integration by parts, and here instead of u I have secant x. Instead of v, I have tan x. Therefore, this is equal to secant x tan x minus integral tan x into secant x tan x dx, which is equal to secant x tan x minus integral tan square x secant x dx, which will be equal to secant x tan x minus integral secant square x minus 1 into secant x dx, which will be is equal to secant x tan x minus integral secant cube x dx plus integral secant x dx. Therefore, I is equal to secant x tan x. This I is again repeated here, minus I plus integral. Don't write it as a formula directly. In most of the guys, they give it as a formula directly. It's not a formula to be applied directly. Just multiply and divide by secant x plus tan x within the integral. I should not take any variable out of the integral. Now for bringing I to this side, 2I is equal to secant x tan x plus, here if you look at it carefully, it is of the form integral dt by t, where my t is the denominator, secant x plus tan x. Therefore I need only I. It is half secant x tan x plus half log mod t plus c. Therefore I will be is equal to half secant x tan x plus half log mod secant x plus tan x plus c. Let me just repeat the whole process again. I take it as I, integral secant cube x dx can be written as secant x secant square x dx. Secant x d of tan x, d by dx of tan x is secant square x, cross multiply dx. Now d of tan x is nothing but secant square x dx, or secant square x dx can be written as d of tan x. You can close with your hand and then find out, this is my u, this is my v, this is of the form u dv, this is of the form u dv, as equal as spoon feeding for you. If you understand this concept, is very simple. Put your hands here, this is my u, this is my e, this is v, this is of the form u dv. Now for the formula says integral u dv is uv minus integral v du, which says here u is secant x, v is tan x, therefore uv secant x tan x minus integral v du, tan x here d of secant x tan x minus integral tan x, secant x tan x dx, derivative secant x is secant x tan x minus integral tan square x secant x dx, secant x tan x minus, this can be written as secant square x minus 1, therefore secant x tan x minus integral secant cube x dx minus into minus plus integral secant x dx. Therefore LH is already I is equal to secant x tan x minus I plus, here don't take it for granted as a formula. You will be given step marks for this particular case. If you don't write it as a formula directly, multiply and divide by secant x plus tan x within the integral. I should not take variables outside the integral. The very purpose here is derivative secant x is secant x tan x, derivative tan x secant square x is there in the numerator. This is the form dt by t, where d is my denominator. Integral dt by t is log mod t. Therefore divide by 2 throughout. I becomes half secant x tan x plus half log mod secant x plus tan x plus c. That is the final answer you are supposed to remember anyway. Okay, it comes under grouping principle. It comes under grouping principle. Anyway, it's already 13-14 minutes. As I already told you, I'd like to restrict all my videos for maximum of 15 minutes for you to understand those two problems exactly and not to feel bored about having so much of minutes in any other video. I'll check for the corrections. If there is any correction, I'll just correct it out. Otherwise, just anyway upload as it is. Thank you students for patient watching.